So let's start it. So good afternoon, everyone. My name is Vihari Adam, and I'm leading the sales department here at QFD Group. Thank you very much for joining us today to our coffee break. First things first, as you might know, I started to record this event. Therefore, if someone does not want to be present with a video picture, or then please shut down your cameras. So again, thank you very much. Today we will talk about the control plan change. The control plan change was introduced in March 2024, but I think it's always good to make a small recap, as this control plan is making part of the core tools of AIAG. So I will give the speech to Beata, our guest, and yeah, let's start the show. Bea, the stage is yours. Thank you.
Okay, thank you very much, Adam. Welcome to everyone. Let me introduce myself also. My name is Beata Varga. I am a trainer and consultant for QFD. And as Adam told you, I would like to speak to you about the control plan changes. So as many of you, I think you have already heard about it, that last year AIAG released a separated control plan handbook, a control plan manual, which is now split off from the APQP manual. Earlier, in the second edition of the APQP manual, it was included also the control plan requirement, or it were the control plan requirements there. But now we have two separated books for that since March 2024, as I mentioned already. So now we have a third edition for the APQP manual and the first edition for the control plan handbook. I just put here to the slide the other core tools books, just to remember this family from AIAG. But now we will focus on the control plan handbook. So here you can see the structure or the content of the volume itself. So we will speak about the control plan requirement specification. I will highlight some specifications. Then the second session is from the volume is the control plan development process. Then the book refers to the control plan phases, the control plan types. And there is a very useful session. This is about the effective use of control plan. And of course, there are annexes in the book. I will also show you some examples from that. So then let's start the most important topics. So about the specification, as I mentioned, I will only highlight something because we have only about 20 minutes. So I wouldn't like to go into the details. First, about the format. The format is not mandatory. So we from AIAG we have a recommendation for the format. But you don't have to use this format. You can use it, of course. You can download it if you buy the volume, but you don't have to use it. But the content of the control plan, this is mandatory. As you may know, it's also written in the IATF standard. In the IATF standard, there is a separate chapter for control plan, and also there is an annex where the requirements, the mandatory content is listed. So that is about the format. Then the next point is the special characteristics. All special characteristics must be included in the control plan, as you know well, I think. Product and process characteristics, so both of them, don't forget it. And with special symbols, so not really changed the requirements. Then the next topic is a little bit more interesting. This is the pass-through characteristic topic. So the organization must identify and document all PTCs, and you have to have a control on at the last point of control of the PTC. So you have to identify, you have to document it, and you have to have a control on it, on the PTC. Okay, error proofing. So all of the error proofing devices must be listed in the control plan. For example, if you have a camera inspection, then you have to have it as a error proofing device. And why is important that? Because the requirement is not only that you have to list it in the control plan, the error proofing devices, but you have to control also the functioning, the well functioning, the well working of this device. So you have to be sure if you start to use this equipment or device that it's functioning well. I will show you an example later on. Just I will speak about the rework and repair, and after that I will show you example for that. A little bit back to this error proofing topic. So, for example, you will use this well-functioning red rabbit parts or master defect parts or dummy parts, whatever. This is also a requirement that then you have to maintain and manage this master defect parts also. This is not part of the control plan. Usually it's part of the measuring device control management process. For example, if you have a measuring device control list, then you can manage these dummy parts or red rabbits there. And for example, you can verify this in every year, because you have to be sure that they are up to date and they are functioning as is designed. Because, for example, a red rabbit has a failure mode, sorry, a failure, and you have to control that is this red rabbit parts, for example, in 1 year later with the same failure is. Okay, and the rework and repair process, I would like to speak a little bit about it. You have to know, I think, that what is the difference between the rework and the repair. So if a product has a failure and you would like to make an adjustment, if you make a rework, that means after the rework you have to have a part which has the same specification as the original one. So customer will get a part which is conform to the original customer specification. If you adjust the part with another material or with another total other process, then at the end the part will be usable for the customer, but it's not according to original specification. So this is the repair. And the big differences between these two, if you have a repair, then you need a customer approval for that, because at the end your part will be not according to original customer specification. From control plan point of view, what is the requirement for this? At the rework, we have to separate two things at the rework. If you make the rework in the original process, through the original process, you take back to the line the part, and the part goes through on the same process, on the same devices as the original one, then you can put this rework into the original control plan, in the serial control plan. Just you have to mark the starting and the end point, the finish point of the rework, where you start the rework and where you finish the rework. The other way to make a rework, when you have a separate workstation for the rework, which is an alternate equivalent process, just not in the original line, but in another. In that case, you have to have a separate control plan for the rework. Okay, this is the difference between the two rework methods. If we are speaking about the repair is always an another thing. So it's not the original process or not with the original materials. That's why always a separate control plan is needed for that. Okay, so repair, always separate control plan. Rework, it depends. If it's on the original process, then not needed a separate one. If it's on other workstation or other alternate process, then you need it separately. So let's see some examples from the control plan book. For example, here is this rework topic. Here in the original control plan, you can see, for example, here is the starting point of the rework, and here is the end points. So you can just mark it as this could be reworked. And the other one where, for example, the error proofing device is controlled. So here we have an inline vision system, like a camera system, as measuring device. We control every part, we check every part with this inline vision system. This is in the first line, and in the second line, in the next line, we can or we should have an additional process characteristic, which is now here the error proofing confirmation, for example. And the specification for that, for the error proofing confirmation, is proper function of vision system. So we would like to be sure that our vision system is working well. And for that, we are using a red rabbit. And usually this red rabbit or master defect part we use at every shift start or at every changeover or tooling change, whatever. So you have to define the frequency, of course. So this is an example for the error proofing description. How can you handle it in the control plan? Back to here. Maybe one other thing is this 100% visual inspection, because a lot of company has 100% visual inspection. In that case, it is a requirement that the control plan must include periodic verification of the visual inspection. About the software, I will speak a little bit later, and I will back also a little bit to the reaction plan details. Let's go on to the control plan phases. The control plan manual refers to the well-known 3 types of control plan phases or types, which is the prototype control plan, the pre-launch, and the production. The prototype control plan is not a mandatory one. It has to be done if your customer is requested it, but the pre-launch and the production control plan are mandatory. So this is here in the control plan manual. It's a specification or a not recommendation. it's a request, and also according to IATF standard. And in the control plan manual, there is a 4th type of control plan, which is the safe launch control plan. Safe launch control plan is only a recommendation, so it's not a must according to control plan manual. But it depends who is your customer, because some OEMs has such a requirement that you have to have the safe launch period. And of course, if you have a safe launch period, then you have to have also control for this time period. Safe launch means, I think you know it. This is at the start of the production when we would like to have plus control and additional control on the products and processes. So we have added inspection items or increased frequency of the checks or of the inspections and monitoring. how long does it take? It depends with the agreement on with the customer. Normally, it's about 3 months. The recommendation of the control plan manual is also 3 months, but it depends really on the agreements with the customer. So there are some suggestions in the manual, not also for the period, but for the exit criteria also. So you have to look at in the manual, or you can join to a control plan training where we will discuss about this. Okay, safe launch. I also show you an example. So if you have a separate control plan for the safe launch, then you have here in the top not only the pre-launch, so the prototype, pre-launch and serial production control plan types, but there is a fourth one which is a safe launch. So you can mark this is a safe launch control plan, and you can have a separately. I don't know why it's not in this form, but somewhere I already, so like here, you can see here prototype, pre-launch, production, and safe launch, and you can mark it, and then you have separately that. Or another option that you can put this additional safe launch inspection to the production control plan. Like here, you can see that the SLP for the 6 process step, and we can see also that during the safe launch period we have a higher frequency than normally in the production serial production. So instead of every 30 parts, we have to inspect or check the parts 100%. So this is for the safe launch period. So there are different methods. How can you make this control plan for the safe launch period? Either you can have a separate control plan, or you can put into the serial control plan, but you have to mark that this is for the safe launch period. Okay. Then about the control plan development. So I wouldn't like to go into the detail at the control plan development, because this is the same. So this is unchanged. We will start with the process flow chart, and after that the risk analysis coming, with the FMEA, for example, and then the control plan is created to define the controls necessary to mitigate the risks. So this is not changed, but it's changed in the format that we have to define a responsible person to the reaction plan. So until now, we had in the old control plan forms only a reaction action here, but not owner or responsible. And now it's added this column here. So we have to add either the owner or the responsible of the action. A lot of companies write here or define here the non-conformity handling process, or handling of non-conforming products, something like that. And in this case, the question, okay, then who is the responsible for that? If I am defining here a process description, then of course the process owner can be written there. You can see also this in the example from the control plan handbook. Here is this column, you can see. And if you have an instruction or a procedure, then you can put there the manager or the process owner. Okay. The next point is the control plan checklist. The control plan checklist is changed. We had earlier a control plan checklist. But now we have 21 questions in the checklist, in the questionnaire. You can find this questionnaire also in this template here. So you have these 21 questions here. It's a very useful tool, I think, if you develop the control plan. So not after small changes, but really at the product and process development process. If you already developed the control plan, then it makes sense to go through on these questions and to be sure that you have to build up your control plan according to the requirements. So I think really useful to do it. Okay, and at the end of this session, I would like to highlight some effective tools to control plans. How can we use better and better the control plans? What are the opportunities in? The first thing is the reverse FME, reverse process FME. The reverse process FME helps to find gaps and weaknesses in the prevention and detection controls of the process. You can use it reactively, proactively. Normally, we are using it in the serial phase already, when we have already the serial process. And you can check with this reverse PFME that we have only that risk what we had in the development phase, or we have more in the meantime. How is our detection control? It's working how we defined it or not. So it's a very good tool, I think, the reverse PFME. As I know well, we will have also a separate coffee break in August for the reverse PFMA, so we can discuss later about this tool. Okay, the next one is using software. Using software to develop and manage FMEs and control plans, it's very effective because you can avoid the duplication, or you can avoid that you change something in the FMEA, but it is not changed in the in the control plan. So if you use only Excel, you can use Excel. Why not? It's it's free of charge, but the effort is much more to manage separately the FME and the control plan in Excel. If you use a software, then maybe you can also use it for the process flow chart. From process flowchart automatically coming the processes to the FME, to the process FME, I mean, and what you are doing in the process FME, it's automatically appear in the control plan. So, and also if you change something in the control plan, then it's changed also in the FME vice versa. So it's very effective way to handle, to manage your core tools or core tool, yeah, the core tools, the FME, process flowchart, FME, and the control plan. Okay, the next tool is what you can use to be more effective. This is the layer process audit. The layer process audit is a verification of the control plan. As you know well, you go to the production and then you can check if the work instruction, the standards, and the controls are in place. So you can verify the well functioning of your control plan. That's it. So this is a checking or verification of the control plan. Then the manual is or manual refers to the highly automated processes as well. I am just looking the hour, so I will finish soon my short training. So you can read also in the book about the family and foundation FMS as effective tool, and we have to consider also the risk related to storage, the material handling. It is also an interesting question because a lot of time we forget these things, this risk related to material storage and handling. And so now we have a lot of electronics and new technologies what we are using, and the risk related to the material and storage it's higher and higher. I mean, temperature, humidity, contamination, electrostatic discharge, and so on. So these are all risk, and we have to have it also in the FME and later on then in the control plan. And you can read also about the abnormality management related to the control plans. So just a short look on some frequently asked questions what we received related to this topic. When will OEM start requiring the new APQ and control plan manuals? My bad news or good news, I don't know. They are already, some OEMs are already required. Ford, GM, Stellantis, they are accepting this new method already since March 2024. And in the meantime, in the last 1 year, they already has as requirement also. You can find it in the IATF customer specific requirement, or the IATF global oversight. .com. You can download it and you can see it. This is already a requirement from them. And also it was a question, or more times a question, that do OEMs expect suppliers to update existing control plans to meet new requirements? No, you don't have to update the old control plans according to new requirements. But if you have a new project since the new requirement, then of course you have to update it, or you have to use the new requirements. Sorry. Okay, so I am just checking the chat box, but I don't see any questions. So thank you very much
If
from
you
my
have
side. But
questions, you
you
can
turn,
write it here,
Adam.
or you
Yeah.
can so for the questions, if you have later on questions, do not hesitate to write us. And yes, sorry to Beata to cut you. Thank you very much for your valuable presentation. Just in an exhaustive style, I just listed here the available trainings, and amongst them, I would like to point out the VDA 6.3 process audit or qualification and exam will happen in June in Ljubljana. And as a last minute call, we can give you now a 10% discount. I think it's interesting, and obviously it is needed for those persons who are delivering to Volkswagen Group. Okay, so thank you very much. If you have again questions, do not hesitate to write us, to send us. We will answer them later on. In the next couple of coffee breaks, we will discuss about the DTLD audit, technical cleanliness, and as just Beata said in August, probably with Beata as well, we will come back with the reverse FMEA. So thank you very much. It's 1:30. And with this, I would like to conclude this presentation. Thank you and have a nice rest of the day.